Everyone agree? Okay. What's our start point?
5,000.
5,000. Okay. And what's our rate of change?
300.
Can I say it's negative 300?
Yeah.
Okay. So we said start with then y equals mx plus b. Because we're seeing an initial amount, okay, a starting point, and we're seeing a rate of change. And so this is the form it's in. It's a linear equation, we'll describe it, and this linear equation will describe it. So all we've got to do then is put the rate of change right there and the initial amount right here. And I noticed a lot of you had it this way as I walked around. Does that work?
Yeah.
Same thing?
Yeah.
Actually makes more sense to me. If this is the start point, then let's put it first. That's fine. Now, are we talking about xylophones and yaks?
No.
What are we talking about? Time and money. Which one's time? Which one's time? X, okay. X is time, and Y is money. And then I'm going to say that money is a function of time. The amount you owe depends on how much time has gone by. It's a function of time. Does that make sense to everybody? Okay, so there's our equation. And there are variables that make sense, and now it is written in function form. You happy? Nikai, you happy? You do not look happy. You had a scowl on your face. I could tell even with the mask on. What's the matter?
He's smiling.
Do you understand this? Does it make sense? Kind of. I guess. What can I help you with? You know. Angel, what do I mean when I say find when the function equals 0? Okay.
I think I might know.
Gage,
100%
go
sure.
for it.
Is it like how many? Like
Yeah, how many? Yeah, keep going.
I forgot how to say it.
You got it. I think you know.
I have it, but I don't know how to say it.
Okay. What are you thinking, Thomas?
Yes, that.
How many months you have to pay? How many months you have to pay until what?
You're
You're done paying.
Yeah, until you're done paying. Yeah, exactly. Yeah, exactly. Okay, so when we look at this function right here, what we want to do is we want to know when it is equal to 0. And so that's literally what we're going to do.
0 equals 5,000 dollars.
Right? So we're just going to put 0 there and figure out how many months we have to pay before we don't have, until we've got it paid off, right? Till we owe $0. Okay. So how do we want to solve this?
Plus 300.
Is it okay if I add 300t to both sides?
Yeah.
You guys got ticked off at me about that the other day because you always want to get rid of the constant.
Nah.
But as long as I get them on opposite sides, right?
Fine. Get the constant.
Okay. So I'm going to add 300t to both sides, and the reason I'm going to do it that way is I want my coefficient to be positive. I don't want to have to divide by a negative. Now it'll work the other way. Totally fine.
It's 16.66666.
So 0.66666, that's 2/3. And the only reason on your calculator it goes to 7 at the end is the calculators run out of space, so it rounds it off. Okay, so since the next number is 6, it just rounds it off to 7. So that's 16 2/3 months. So after you pay 16 months, then that last month you're actually not going to have to pay $300. You're only going to have to pay 2/3 of that. What is 2/3 of $300? 200, yeah. You're going to have to pay. So on that, after 16 months, on the 17th month, you're only going to have to pay $200 to have it paid off. Okay?
$300 a month, that's not bad for money-wise.
Yeah, especially for rhinoplasty. I mean, that'd be totally worth it.
What is that? What is that?
Plastic surgery on your nose. I wondered if you guys, I was surprised no one asked me about that earlier. Anyway, so, let's see, money of 16 2/3 equals 0, doesn't it? Okay, so let's go to our graph. So this thing doesn't seem to fit real well on this graph, does it? But we can make it fit. The x-axis, remember, 16 2/3 is where we're at 0. So we only need to go out to 16 2/3. So I think what I'm going to do is I'm just going to go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I'm just going to change things to be 2's. And then going up the axis, what we'll do is we'll just change these to thousands. So I'm just going to say this is money in thousands. So this is 2,000, 4,000, 6,000, 8,000, 10,000. You okay with that? And then we're not even going to worry about the other quadrants, are we? We're not going to talk about time negative anything, and we're not going to talk about money negative anything, are we? So at time 0, we're at 5,000. That's our initial amount. And then at 16 2/3, the money is down to 0, isn't it? So that's our x-intercept. Right? So it's not just the y-intercept that's important in this problem, is it? It's not just how much you owe at the start. It's when do you owe $0. And so we can make our graph now, depending on how you label this, your graph can look kind of different, can't it? What if I said this is 1,000, 2,000, 3,000, 4,000, 5,000? Then wouldn't my graph look a lot steeper? So, you know, it's going to depend, and you need to make sure that you label everything very carefully. And I guess we should probably change this to time right here. Time in months.
That wasn't bad.
I wonder if we're going to have a test with something like this on it on Friday.
No.
Maybe we should just skip that.
And it should be worth it.
When we have the test, I'm going to give you a graph on the test that's probably just going to look like this. And then you guys can label it however you want and make it a little bit easier on you. Okay? Can you guys think of any time when we wouldn't use the first quadrant, where we would only be interested in the one of the other quadrants? What's that? Yeah, when we're talking about some kind of negative. So I don't know. Let's say you're in a submarine. What's your depth going to be? Yeah, you're gonna have negative depth up to 0, right? And hopefully never above 0. You're not gonna like jump the submarine out of the water or something, right? Probably be a bad idea. In chemistry, listen. In chemistry, there are a lot of times when the temperature that you're looking at is negative, or the pressure inside of a cylinder is negative. So in science, biology, chemistry, physics, there are a lot of times when we're looking at negative things. So we would be looking at maybe this quadrant down here. Time might still be positive, but the pressure in something might start out kind of negative and then go even more negative or something like that. So it's not always the first quadrant that we're looking at.
Or when you owe the bank an IOU.
Yeah. And if, heck, what if we did this and we were the bank and we were thinking of the $5,000 we lent somebody as a negative and what they're paying us every month as a positive? That would change things, wouldn't it? Yeah. Okay, so yeah. Okay.
What if they can't pay you back? Like,
What if what?
What if like they can't pay you back, like they lost their job?
Okay, so in Huntington, for example, Main Street in Huntington, there's the Desert View Federal Credit Union. Okay, right there on Main Street. It's right on the corner. Looks like this. Okay, so there's a building right there, and this is Main Street in Huntington. And right there, you'll notice there is a silver pickup parked right there. Okay, and there's also a motorcycle parked right there, chained to the light pole. Okay, so in both of those cases, someone has defaulted on their loan. Okay, which means that for whatever reason, they didn't pay the money back that they borrowed to buy that truck or buy that motorcycle. And so those vehicles have been repossessed by the bank. So they send somebody out and go get them from you, or you just bring it to the bank, hopefully on your own, and say, I can't pay this back. And that vehicle is the collateral for the loan. Okay, so the collateral means it's something you're putting up in lieu of the money. So if you can't pay it back, then this goes back to the bank, and then they have those for sale, and they're gonna sell those to someone else to pay back that loan. But it's not quite as simple as, oh well, I just can't pay it, so here's my truck. That also goes against your credit score. So guess what happens next time you want to borrow money to buy something? You think someone's going to lend you money? No. Or if you can find a lender that will lend you money, they're going to charge you a much higher interest rate than someone who is good about paying their loans back. Okay? So you'll hear sometimes people will say, we can approve anyone for a loan for a car. I hear that a lot. What is I can't remember, but well, yeah, they can approve you to buy a car. They can get you a loan for that car, but I might pay 2.89% if I buy a vehicle, and someone who has bad credit, they might be paying 10% for that vehicle because they're a higher risk. So overall, I might pay $5,000 in interest over the life of a loan for a really expensive truck or something, and they might pay $20,000 in interest.
Wow.
Yeah.
Damn.
Okay. So it's not just as simple as, oh, here's my vehicle back, or you might just not be able to get a loan, or you might go to rent an apartment, and they won't rent you the apartment because you have bad credit. They can't trust you to pay that. Okay. So only borrowing on things that, now you can buy, when you get a loan for a car or something, you can buy an insurance policy on it that kind of covers it if you lose your job for some reason. Like if COVID comes and your business gets shut down, you may have some type of insurance that you've purchased when you get the loan that might cover you if you lose your job or something like that. But it's something that you have to prepare for. Okay, so good questions. Today we're going to be graphing equations, functions again, okay? And we're going to be graphing some that look like this, and some others that look like this. Do you remember what these look like? Okay? So first of all, let me make this clear. You're going to draw your own graphs today. Okay? You're going to use some kind of a straight edge. You can get a piece of paper from me and fold it over and keep it all the time if you want. You're going to make your graphs at least that big. Everyone see it? So you could probably put 4 on a page, just like the graphs that we hand out. You're going to put arrows on the ends of your graph, and you're going to label the axes. So this is what your graphs are going to look like. Okay? The x-axis is going to be directly on top of a blue line. So the blue line on your paper, you're going to put that x-axis right on top of it. That'll help you get it nice and straight. And then each blue line that goes up and down is going to be a 2. So you're going to say, okay, this is 1, 2, 3, 4, 5, 6. That's going to help you get that. Now you don't have to label all the way up to 10 and -10, and just make the marks on the graph that you need in order to graph it. So if I'm going to graph y equals -2.5, I'm just going to come over here, -1, -2, -3. There's negative y equals, is that right? Oh, that's what? Okay, but doesn't it go the same direction as the y-axis?
Now I'm confused. Now you're confusing me.
Okay, so what does this line do? Does it go the same direction as the y-axis? Okay, so I hear you guys, somebody saying it goes through, right? So it goes through the y-axis at -2.5. So, not the same direction, through. And you're gonna draw it nice and straight. You're gonna put, ooh, that wasn't very straight, was it?
Wait, so the first mark, I was just wrong.
Yeah, I was just bugging you.
Alright, that confused me.
Okay. So there it is, and then you label this one, y equals -2.5, and this is number 2 or whatever it is. Okay, so what about this one? Y equals 4.
It's going to be undefined. I'm calling it right now.
Well, its slope is undefined.
Goes straight.
Okay, it goes through the x-axis at 4. So it's not a function, because no matter what, you can put 4 in and get different outputs.
Wait,
But it is a line. Its slope is undefined. It's not a function, but it is a line when we graph it. It's just a vertical line. Yeah.
wait, so do we have to make our own graphs for each of those? Or can we
You can put 2 on one graph.
Okay.
So this can be number 3, x equals 4, and you can put both of those on one graph. So you just need to remember, if it's y equals something, make sure it goes the same direction. Or, excuse me, if it's y equals something, it goes through the y-axis at that point. X equals goes through the x-axis at that point. Okay? Now, the other ones you are going to be graphing today are going to be in standard form. And we've been doing this for some time. And we've talked about how to graph these, haven't we? Okay? And we use what's called the double intercept method. So you make a table, and you say, what if x were a 0? Say it, Dane. What equals 3? Y is a 3. If x is a 0, that's gone, isn't it? And y equals 3. Okay, so that's a point that we can graph.
If y was a 0, then x is 4.
Yeah. Yeah. So 0, 3. Make sure you graph 0, 3. Okay? And then if y is a 0,
X would be a 4.
That's right. X is going to equal 4. So 4, 0, 1, 2, 3, 4. And there's 2 points. And do we need more than 2 points to graph a line? Nope. So we can come over here.
Thank goodness for 0. That's all I'm saying.
Yeah. Thank goodness for 0. That's true. Now, this one's nice and pretty. The x-intercept and the y-intercept are whole numbers, or at least they're integers, okay? That's not always the case, and that's okay. So you might have something that says 5x minus 2y equals, let's say, 15. So when we go to graph this, we say, well, what if x is 0?
That's like 7.5. Something like that.
Okay, 7.5. Is that a thing? Is 0, 7.5? Is that there?
Yeah.
Sure. So this is 3, 4, 5, 5, 6, 7. There's 8. So 7.5. You okay with that?
Yeah.
So the y-intercept 7.5. The x-intercept.
Is there going to be fractions?
So what's the x-intercept? Yeah, that's right. Just 3. And we can graph the line. And how many can you put on each graph?
2.
Yep, 2 on each graph. So this is called the double intercept method. You're finding the x-intercept and the y-intercept. And like Matt said, thank goodness for zeros. This is not anything new, is it?
No.
No, we've been doing this for a long time.
Wait. Question, is there going to be fractions? Like this?
Sure, yeah. There'll be times when you have fractional intercepts. It's not always whole numbers. Yeah.
So we can do 2 questions on one graph.
Yes.
So like, even if
But yeah, but I did this in black and blue so we knew what's going on. But you guys might say this one's number 12 and this one's number 11 or something like that. So make sure you label them so we can see what's going on. And don't put more than 2 on one graph because it kind of. Everybody turn to page 132 now. And I will get out my glasses so I can read this thing. Okay, so I'm looking at example 3 right at the top. Everyone there? Okay. Cadence, read that really loud for everybody.
We are planning an award banquet for your school. You need to rent tables to seat 180 people. There are two table services available. Small tables seat 6 people and large tables sit 10 people. The equation 6x plus 10y equals 180. The model to this situation, where is x the number of small tables and y is the largest number of large tables.
You guys get all that?
Yeah, kind of.
I didn't hear any of this.
Yeah, kind of. Okay, so she did a great job reading it.
No.
You have 180 people coming to an awards banquet. Okay, and you are getting small tables and big tables. The small tables sit 6 people, and the large ones sit 10 people. And I don't like X and Y. X and Y are stupid. What is X in this problem?
Small tables.
Small tables, S. What is Y in this problem? Big tables, B. All right, now I'm happy. X and Y, I mean, that's fine on the graph, but it just doesn't make sense in our problem, does it? So 6 times the number of small tables plus 10 times the number of big tables needs to equal how many people? 180. That's what we want to happen here. Okay? And so we look at the intercept. So we go to graph this thing. Okay, so we have small tables and big tables. If S is a 0, What's B?
18.
Okay. What does that mean?
That
There's 18 tables.
you're typing.
Okay, if I have 0 small tables at the banquet, I can have 18 big ones, and I can still sit 180 people, right?
Yeah.
Okay.
Okay.
What if I have 0 big tables?
You need
30.
a lot.
Okay, we need 30 of the small tables in order to equal 180 people. So I could have 30 small tables, 0 big tables, and I could still sit the 180 people. Okay, now let's look at a graph for a second. Okay, so I want to put this on a graph. Mason, I'm not ignoring you. I'm just ignoring you for a second. Okay, so we don't have X and Y axes here. What do we have?
Big tables and little tables.
Okay, which one is this axis? Small tables, because that's where X was in the first place, right? You could change it if you wanted. And this is the big table axis. And we've got 0, 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. And then we've got 30, 0. So 5, 10, 15, 20, 25, there's 30. So I labeled the first 3, and then I labeled the one I'm talking about here, 30, 0. Okay. You don't have to label every one. These I didn't have to label because each of the marks represents a what? I'm going up.
Oh.
They're each ones, right?
I meant you meant big marks.
Okay, so 0, 18 works, 30, 0 works, but are there other combinations here that will work?
Wait. Okay.
Like, could it be possible to get a few small and a few big ones? Like maybe 15 of the small and 10 of the big ones, something like that.
Yeah.
Right? Now it's hard to tell here. Now I made a solid line like this was a continuous problem, but I think it's more like a discrete problem, because I don't think we're going to get 2.5 small tables or 3.75 big tables. Isn't this actually going to be like dot, 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 dot?
Yeah.
Right?
So
But anyway,
do you want us to dot it, or can we just try a line?
you can draw the line.
Alright.
Yeah, you can draw the line. So that's what it's talking about, is it's just all the different combinations that will work out. This type of problem, super common. We're gonna look at a bunch of these. Okay, now I'm done ignoring you. Go ahead.
How do you get 18 and 30?
Okay, I put a 0 right here. Okay, so instead of S, I put a 0. 6 times 0 is 0.
Right.
So 10b equals 180. And then I divided both sides by 10, and b equals 18. Okay, and then I put a 0 right here. 10 times 0 is 0, so 6s equals 180. And I divided both sides by 6, and that's where I got the 30. Okay, so I plugged in the zeros and figured out what comes out, and then I have my 2 intersects. Okay, and in this problem, they actually have some meaning, don't they? If I get 18 big ones and 0 small ones, that'll work. 30 small ones, no big ones, that'll work. Or some combination of both will work, won't it? Okay? All right. Are you glad that we did a lot of this double intercept method before now? Today's not the first day we're talking about it, is it? So chapter 3.4.
Alright, give us Okay.
I'm gonna give you a lot of time to do it in class. We're gonna have time to do it in class, but I want nice, neat graphs. I want them to look pretty. The more I write, the better it is, because that means the more I'm leaving out. If I just say 1 through 42, that'd be a lot of problems, wouldn't it?
Yeah.
But every time I kind of skip and go back and forth, that means I'm leaving stuff out. So the longer it looks, the better off you are.
That is true. Alright, let's get.
Let's go.